Hi guys, you're welcome to my channel. So today we are going to commence our lecture back the way we used to have it before. I've always been having a busy schedule, so I don't really have the time to stand before board and shoot video. So let's give a very big thank you to Topaz, who actually sponsored this means of recording video using a tablet. And she did this because she's having exam by this weekend, and she would like us to make some videos to clarify some topics she's having difficulty with alongside with her friends. So let's wish her success, because this is a very great thing that she has done for us here. All right, so today we are going to be looking at theory of set, that is set theory, and I'm going to divide this lecture into two. I'm going to talk about the properties of set, everything that has to do with set in part 1, which is the video that we are on now, and the second one is going to be on Venn diagrams. So without any further ado, let's jump into the class. So what is a set, if somebody asks you? Okay, very simple. When I say a set, what are they simply talking about? So we are talking about a well-defined, the collection, let me put it like that, yeah. Set is the collection of well-defined objects. So this is what we refer to as a set. Do you get this now? So when you say a set, you are talking about the collections of well-defined objects. And what do we mean by well-defined objects? Objects that there is no interruption in its description. That is, the description is just clear. Just like if I say set of females, it means there is no opposite gender in their means. They are all females. That makes it a set because it's well-defined. If I say set of students, it means you won't find workers or teachers among them or parents. They are all students. That makes it uniquely defined. And you now hear me saying that a male and a female, they are set of they are set of females, yeah, or say set of male when you have the opposite gender in it. So it's wrong to say that. If I have male and female, I can say they are set of human being. Are you getting it now? So that set is well defined. Do you understand that now? If I say set of states in Nigeria, you are not going to find a state in another country in that midst. So you are going to have what? Just the state in Nigeria only. That make it what? A set. And you are not going to find capital inside what? State. Are you getting it? It's basically states. So when they say a set, it's a collection of well-defined objects when there is no mix-up. It is purely what it is. Anything that looks like it will not be there, but what it is. That's what they mean by what? A set. Now that we have understand this, what's the next thing that we need to understand as far as set is concerned? When we talk about set, we talk about what we use to represent a set. A set is represented, that is, if I want to write a set, is represented with capital letter. So if I say a set A, it means it has to be capital letter A. If I say a set B, it has to be capital letter B. If I say a set Q, it has to be capital letter Q. Now, this is not the only thing we use to represent set. In set, we have a special bracket that we use in representing set. That is, if I write down that A is a set of number from 1 to 10. So I'm going to write it that A is equal to set of number from 1, 2, 3, 4, 5, 6, 7, 8. Always put comma. 8, 9, and then 10. So, and I'm going to have my bracket back like this. Now, if you look at this bracket, you get to see that it's quite different from this bracket. That is, this particular one here is different. And it's different from this bracket. And it's also different from this bracket. And it's also different from this. Okay, sorry, it seems I have this before. So let me clean this off. All right, so I mean it's different from these brackets. All of these are brackets, but they are not brackets that you can use for a set. This is the only acceptable bracket for a set. Are you getting it now? It is called the curl bracket. Are you getting it now? Curl bracket. So you use capital letter to denote a set, and you use this particular bracket. Now, why all these ones are not set? Now, this particular bracket you have here is called an interval, a closed interval. This bracket is used to represent what? A closed interval. Why this one is used to represent an open interval? Why this one is used to represent half closed, half open interval? And this one is used to represent what? Half open, half closed interval. And I want you to understand something, that an interval is a set, but a set is not an interval. Do we understand that now? An interval is a set, but a set is not an interval. So whenever you are writing a set, it must be a curl bracket. So I know most of us always find it difficult to write, but it's a thing that we can practice, and with time we get to know how to write this. Are you getting it now? Okay, so that is the set notation. A set is denoted with what? Capital letter, and we use what? Curl bracket for a set. Are you getting it now? So if I say, for instance, if I say P is a set of prime numbers within 1 and 10. So it means that I'll write down capital letter P, and I'm going to open my curl bracket, and I'm going to look for the prime number between 1 and 10. So if you look at this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what are the prime numbers between 1 and 10? So you remember, prime numbers are those numbers that have two factors only, that is 1 and itself, right? So if that should be the case now, so 2 is what? A prime number. 3 is a prime number. 5 is a prime number. 7 is a prime number. And I think that's all. Now mind you, 9 is not a prime number. 6 is not a prime number, and 1 is not a prime number. So within 1 and 1 and 10, the prime numbers we have there is what? 2, 3, 5, and 7. Do you understand that now? So if you notice what we have done here, I have represent the set with capital P, and at the same time I've used what? Curl bracket for the set. That's what we use to represent a set. I believe we understand that aspect now. All right, guys, so if that should be the case, now let's talk about the element of a set. Okay, so we talk about the element of a set. So let me clean this off. All right. Okay, so I want to talk about the elements of a set. Now, when you talk about the element of a set, what do we mean by elements of a set? We are talking about the items that you have in a set. Elements of a set. All right. So this simply means what? The items that we have what in a set. So the element of a set is denoted with a small letter. Are you getting where I'm coming from now? So if I say A is an element of a set, so I use what? Small letter. Are you getting this now? So if I say B is an element of a set, I use what? Small letter. If I say C is an element of a set, I use what? Small letter C. Are you getting this now? Now, if that should be the case, what does it mean? It means that these are the items that you are going to be having in a curl bracket. So let's take for instance that I have that Q, for example, is equal to a set of 1, 2, 3, 4, 5. For example, like this. This is a set of 1 to 5, right? Now, all of this, that is 1, 2, 3, 4, 5. It is called element of set Q. Are you getting this now? any other number outside this 5 number is not going to be an element of set Q. Do you understand that now? Because it's not inside this bracket. Now, how do we write that in terms of notation? So if I want to write that in terms of notation, for example, if I want to write that 2 is an element in Q, I'm going to write it that 2, can you see? And I'm going to use this sign. This is E. This simply means belongs to, and I'll write Q. So what this implies is that 2 belongs to Q. Have you seen it now? That simply means that 2 is an element in Q. And I can write it, if I want to write that 7 is not an element in Q. So what I'm going to do is that I'll write down 7, and I'll write down the same symbol, but this time around I'm going to cross it. Sorry, that crossing is not perfect, so all right. Sorry, I'm just trying to master my tablet, so very soon I'll get used to it, guys. Okay, so this is what E, and I'll just cross it like this, then I'll write down what Q. What this one simply means is that what 7 is not an element, that is 7 does not belong to Q. Do you understand that now? 7 does not belong to Q, but 2 belongs to what? To Q. Do you understand that now? So we need to understand that as what is it called? As far as set notation is concerned. Do we understand that now? So 7 is not an element in Q. 2 is an element in Q. Alright, so you can pause the video now, and I want you to write down that 4 is an element in Q. I want you to write down that 4 is an element in Q. Alright? Okay, so you have done that. So let's see if you are correct. So if I want to write that 4 is an element in Q, I will write down what? 4, and I'm going to, sorry. Okay. Sorry, I think I'm having an issue with my network. Hold on, guys. All right. So if I want to write that 4 is an element in Q, what am I going to do? I say 4 belongs to what? To Q. Correct. Can you see that now? And if I want to write that 8 is not an element in Q, 8 does not belongs to Q. Can you get that now? So it's just as simple as that. So don't let us waste most of our time there. So I believe we have understand that now. So that is that's that for elements of a set. All right. Okay. Okay, so we're still on element of a set. So I believe you all understand this now. So let me rewrite again. If I want to write that P is a set of 1, 2, 3, 4, 5. So for me to write that 5 belongs to P, I'll write this. 5 belongs to P. 6 does not belong to P, I'll write this. 6 does not belong to P. Can you see that now? So it's just as simple as this. Alright, so if there's any other thing that you're not getting right as far as this is concerned, then you can let me know in the comment section. So but I believe this is clear enough, right? Alright, so if that should be the case, let's move on to the next thing on this. Alright, so what's the next thing we have to look at here? The next thing we have to look at here is the number of elements in a set. Numbers of elements in a set. So, okay, I think I can clean this up. numbers of elements in a set. All right. Number of elements in a set. Okay, so this is the next thing that we need to look at, how to find the numbers of elements that we have in a set. Now, number of elements in a set is also regarded as the cardinal of a set. So when they ask you to find the number of elements in a set, they are simply asking you to look for the cardinal of a set. Now, let's take for instance that I have a set A, just like this, and I have elements in it to be 2, 4, 6, and 8. So these are the elements that I have in A. Now, the question now is, okay, let me give another one. Let me say I have the second set B, and the element that I have in it is A, B, C, D, E, F, G, H. Okay, so these are the elements that I have inside the set B, right? Now let's take for instance that the question says find the numbers of elements in A. How do we write that? If I was to find the numbers of elements in A, I will have what? N into bracket A. This is what it means. This is what it means by looking for what? The numbers of elements in A. You write N into bracket what? A. Now the kind of bracket you are using here is a normal bracket, not the curl bracket this time around. So, and then you come to count 1, 2, 3, 4. How many elements do you have there? So that is 4. So the cardinal of A is 4. And if you are looking for that of B, you use N into bracket B, then close the bracket. So you count 1, 2, 3, 4, 5, 6, 7, 8. So you have what? The numbers of elements in B to be 8. Do you get that now? So I think this is my 8 is bad. So let me clean it up. All right, fine. So this is number 8. Can you see that now? So that's how to find cardinal of a set, and it's the same thing as the numbers of elements in a set. Now, if I may quickly ask you now let's make it a bit confusing or complex kind of. Let me say I have let me delete this. Let me say I have an element or a set of P. Let's say this is a set of P, and is equal to I have 2, 2, 2, 2, and I have 7, 8, 8, 8, like this. If this is what I have as my element, and the question now says find the cardinal of P, just like this. Find the cardinal of P. So what will be we count the numbers of elements that we have inside P, right? So and that will be 1, 2, 3, 4, 5, 6, 7. Abi, right? Okay, so you want to write down 7, right? No, the answer is not 7. When you have a set and you have a number repeating itself inside a set, that number is still 1. So if I have 2, 2, 2, the number that I still have here is still just a single 2. Even if the whole element inside this bracket is 2, you just count it as what? As 1. Therefore, these repeated numbers still remain what? 1. For that reason, this is going to be what? 1, 2, and 3. So that's tell you that the cardinal of P is 3. Is that taken now? So repeated element in a set is counted as what? As 1. Is that taken? Also, if you decided to rearrange elements in a set, it's still the same set. For example, if I have that, let me collapse this. For example, if I have that P is equal to set of 1, 2, 3. And I have that Q is equal to set of 3, 1, 2. Or I have it that it is equals to set of 3, 2, 1. Or I even have this to be set of let's say is equals to 2, 1, 3. Anyhow I want to arrange it, all of these, they are still P. Are you getting it now? Irrespective of their arrangement. I believe you understand that now. And that is that about the numbers of elements in a set. So when you are asked to find the numbers of elements in a set, all you just need to do is to count the numbers of elements that you have there. That is the elements you have inside the set, count those numbers, and that will be your what? The numbers of elements. And it can also be called what? The cardinal. That is K-A-R-D-N-A, cardinal of a set. Is that taken now? Alright, so if that should be the case, we can now move on to the next one. So this is cardinal of a set. I think there is L there. So this is all about the aspect of numbers of elements in a set, and I believe you understand that now. So if that should be the case, let's just move on. Let me quickly clean all of these. All right, so all right, okay, so we have this last one here. All right guys, so what's the next thing we want to look at now? The next thing we want to look at right now is we want to look at the subset of a set. All right, so subset of a set. So yeah, that's the next thing we want to look at. Subset of a set. Subset of a set. So what do we call the subset of a set? When I say a set is a subset of another, a subset is a set within another set. That is a set that contains another set, or a set that is inside another set. Now you're going to understand what I'm saying better now. Let's take for instance that I have set X, and set X is just equals to what's happening? All right. All right. So let's back to class. So if I have set X that is equal to the set of 3, and I have 5, 6, 7, 8, 9, and 10. So I have set Y to equals to the set of 5, 7, and 8. If this is what I have now, the set X is what? 3, 5, 6, 7, 8, 9, 10. And set Y is 5, 7, 8. Am I making sense now? So Y is said to be the subset of what? X. You know, I'm trying to explain the concept of what? Subset now. So if this is set X and this is set Y, Y is said to be subset of X. Why is it going to be subset of X? Because the whole of the elements in Y, they are elements in X. Do you understand that now? The whole of the elements in Y, they are elements in X. Is that taken now? So for that reason, X is said to be what? Is said to be written as Y subset of X. So when you see this symbol, what it means is that Y is a subset of what? Of X. Do you understand that now? That simply means that what? Y is an element. Y has an element that is inside what? X. That is what it means that Y is a subset of X. I believe that is clear. All right. Now, is a proper subset of X. Another thing that you need to note: Y is a proper subset of what? X. Why is it a proper subset? It's a proper subset of X because it does not contain the whole of the elements inside X. It only contains some part of the elements inside X. Supposing that it contains the whole of the elements inside X, then it is a subset of X but not a proper subset. Do you understand that now? So that is what you need to understand under subset. And you need to know that an empty set is a subset, and a set is a subset of itself. A set what is a subset of itself. Do you understand all of that now? Okay, so if that should be the case now, the next thing we want to look at is like common question that they always ask us under subset is that how can we find the numbers of subsets that we have within a set? Now I'll take it from simple to complex, and that simply means I'm going to start from a very simple one. Okay. Okay, so let's I don't know what's happening. This thing is refreshing. All right, so let us look for a way of finding the numbers of subsets that we have in a particular set. Now this is also referred to as power of a set. When somebody asks you to look for what are the numbers of subsets in a particular set, what it simply means is that they are asking you to find the power of that set. Is that taken out? Now let's take for instance that I have P as a set and is equals to 3. That is, 3 is a set, P is a set, and the element in it is what? Is 3. Now the question is, find the power of P. Find the power of P. Or the question can be that find the subset of P. To find the subset of P, so we write that subset of P is equal to 3 can be what? Subset of P, right? So because a set is a subset of itself, so we have 3 to be what? A subset of P. Is there any other number that can be? Yes, there is. There is an empty set. Now note, an empty set does not mean a set that contains 0. Let me use another color to do that here. If I have something like this, though we are still going to talk about what? Empty set as we move on. Okay. Now if I have something like, okay, if I have something like this, let's say I have a set like this. If I have a set that contains 0, this is not an empty set, though I will still talk about empty set when I'm talking about type of set. But when you have something like this is not empty. But when you have something like this is what? An empty set. So if I'm looking for a subset of P, you know, P is what? Is a set of 3 only. So the subset of it is going to be 3 and empty set. So that means how many sets do we have? 1, 2. So the subset of P is equal to 2. Do you understand that now? Subset of P is equal to 2. So I can put it there, that the subset of P is equal to 2. Now let's take another example. Let's say I have Q, and these are how I used to write my Q so that you're not going to get confused. So I have Q that happens to be a set of let's say 1 and 2. So I'm looking for the subset of Q. So for us to be able to get the subset of Q, all I just need to do is to, like, 1 can be the subset of Q. It's also possible for 2 to be the subset of Q. Are you following? And it's now possible again for 1 and 2 to be the subset of Q, that is Q itself can be the subset of itself, since a set is a subset of itself, and what? And an empty set. So if you count the numbers of subsets we have here, we have 1, 2, 3, 4. So the subset of Q is equal to what? 4. Am I making sense now? Alright, so if that should be the case, okay, let me just shift this here because because I'll still need it later, and that's why I don't want to clean it up. So let me just shift it up. Alright, okay, so now let's look at the next one now. We have looked at Q now. Let's look for another set. Let's say set R. Let's say set R. Sorry. Okay. So let's say set R is equal to the set of 1, 2, 3. For example, set R now contain what? 1, 2, 3. Now, if this is what we have in set R, what's going to be the subset of R? So subset of R is going to be, we can have it to be 1, we can have it to be 1 and 2, we can have it to be 1 and 3, we can have it to be 2 and 3. Are you following? We can have it to be 1, we can have it to be 1 and 2, we can have it to be 1 and 3, we can have it to be what? 2 and 3, we can have it to be 2, and we can also have it to be 3. Sorry, there's a mistake there. So we can have it to be 1, we can have it to be 1 and 2, we can have it to be 1 and 3, we can have it to be what? 2 and 3, we can have it to be 2, we can have it to be 3. Okay, I think this is not that neat. Let me clean it up. Alright. Okay. Alright, so okay. Well, let's say I have a set R which is equal to what? 1, 2, 3, and I'm looking for its subset. So subset of R is going to be what? I can have it to be 1, I can have it to be 2, I can have it to be 3, I can have it to be 1 and 2, I can have it to be 2 and 3, I can have it to be 1 and 3, I can have it to be 1, 2, 3, 1, 2, 3, because a set is a subset of itself, and an empty set. So let's count this. We have how many? 1, 2, 3, 4, 5, 6, 7, and 8. So the subset of R is going to be what? It's going to be 8. Am I making sense now? So how do we find this? This is taking much time for us to be able to determine. Now, if you look at this very well, you get to see something. I don't know if you are noticing the pattern. You get to see something like, you get to see something like when we have the numbers of elements inside this set. When we have it to be 1, the subset is 2. When we have 2 elements inside, the subset is what? 4. When we have 3 elements inside, the subset is what? 8. Can we just say, since everything we are having here is like an even number, like 2, 2, 2, 2, can we just say that a subset can be written as 2 raised to power n? Like if I'm giving an element now, and I have to look for the subset of that element, I don't need to waste time. I can just write it as 2 raised to the power of what? N. And what does that mean? It means n is the numbers of elements that we have in that set. And if you look at the first one, we have just one element. We can write it as 2 raised to the power 1, and that will give us 2. And you can see we have the subset to be 2. And when n is 2, that is when the number of elements is 2, we can have it to be what? 2 raised to the power 2, and that will be what? 4. And when the numbers of elements is when the numbers of the element is 3, we can have it as 2 raised to the power 3, and that will just be what? 8. So that is a very simple way of looking for what? Subset. And if you agree with me, we can just generalize that whenever we are looking for subset of a set, the subset of a set is equal to, the subset of a set is equal to 2 raised to power what? N, where n is equal to what? Number of elements in the set. Let me put it like that. Numbers of elements in the set. So that's just that about subset of a set. So what's the next thing that we need to look at now? Okay, I know somebody is like asking that we should test that formula if it's going to work for another thing other than that. Yes, it will. All right, I'm coming out. I want to clear the board. All right, so let's have this now. Yeah, we're able to clear the board now. So let's take, for example, if I have let's take for example that I have a set of okay, let me use my name, Toib. A set of T equals to, there's a problem with let's clean this again. We don't know what is happening to this. I think our board is doing anyhow, so let's chop it up. Okay, now let's take for instance that I have T as a set, and it's equal to let's say A, B, C, and D. Now this is the element, and I'm looking for the subset of what? Of T. All I just need to say is that the subset is equal to 2 to the power of n. So where n is the numbers of elements here, so I'll just count 1, 2, 3, 4, and that will be 2 raised to power 4, and that is just 16. So it means that the subset of this set is going to be what? It's going to be 16. And I think somebody understand that clearly now, right? All right, so if that should be the case, guys, let us move on to the next thing. I know somebody's about to ask me that, what about superset? Yeah, we have superset also. If I have for example, if I have that A is a subset of B, then B is a superset. Sorry, that's not what I want to do. Then B is going to be a superset of A. Sorry. Then B, what's happening? Sorry guys, I'm just trying to master this, and I also want you guys to see so that when I start improving in it, you'll be able to testify that yeah, I'm definitely improving using tablets. So this is my first video using it, so I have to be vulnerable, and that's why I don't want to cut anything out of this video. I'm going to show you guys everything. All right, so if I have that A, like I was saying, is a subset of B. And when I say A is a subset of B, you all know what it means, right? That is, you can find the elements you have in A inside what? Inside B. Then it means that B is a superset of A. And what does that statement mean? It means B is what? Is the set that contains the elements you have in A, or vice versa. Is that taken out? Or A contains elements that is in what? B. So, and that's just that about superset. So this one is for superset, that is when you do your right elbow, and this one is what? This one is for subset when you do your left elbow. So it's pretty much simple like that. Yeah. All right, so let's wipe up the board once. All right, so awesome. So what's the next thing we want to do now? We want to look at algebraic notation, and that's very, very important. Yeah, like very, very important. If I finish this class without talking about algebraic notation, then I'm yet to teach anything as far as set is concerned. So algebraic notation is one of those ways that examiners always want to use to understand if you know properly. Sorry, remember we are still a novice in this thing, so just manage. What's happening? Yeah, okay, that's no problem. Right, okay, so sorry for the misflow of the class. All right, so want to look at algebraic set notation. Okay, algebraic set notation. Algebraic set notation. Algebraic algebraic set notation. Algebraic set notation. All right, okay, so want to look at algebraic set notation yeah. So this is the next heading now, algebraic set notation. What does that mean by algebraic set notation? There's something we call set builder. There's something we call set builder. And set builder simply means that you're not going to be given the element that is inside that particular set. You are going to be the one to fill the element yourself. And for this reason, there's need for you to understand some terminologies. Now let's take for instance that I have an element like, let's take this one as the first one. Let's say I have set P that's equal to, let's say I have set P that is equal to the set of X, and I have these two dots, and I have X is a prime number. X is a prime number less than 25. Let me put it like that. Yeah. Now, how can you interpret this question? You know, these two dots that you're having here, this is P, then X. Let me see if I can write it just on a single row. I think that will be best explanatory like that. Let's see. Okay, the first one, if I have that P is a set of X, then two dots, then I have that X is a prime number. X is a prime number less than 30. Now, what does this statement simply mean? I'm going to interpret it. Whenever you see these two dots, let me start from here. P is a set of X. That is what it means. You read it as what? P is a set of X. Now, what does this two dot means? The two dots in some textbook, you can see it as two dot, or you see it as just a straight line like this. If you see it as two dot like this, that is this and this, you have two dot like this, or you see this, you read it as such that, you see that now, such that either you see this or you see this, you read it as what? Such that. So let's read this statement together. P is a set of X such that X is a prime number less than 30. P is a set of X such that X is a prime number less than 30. So they can either use these two dots or they use this straight line. All right. So if that should be the case now, let's wipe this off. If I want to write out the elements of P now, I'll write P is equal to the set of prime number less than 30. That's going to be what? That's going to be 2. We have 2 there. We have 3 there. We have 5 there. We have 7 there. We have 11. We have 13. We have 17. We have 19. We have 23. We have 29. And I think that's all. So these are prime numbers less than what? Less than 30. So you can see that we have been able to build what? Set P. So that's what we mean by what? Set builder. Is that taken now? So let's look at the second example of algebraic notation. The second example of algebraic notation is if they give you something like this. Let's say set Q is equal to let's say X again. And I have X, and I have this, then I have Z, then I have 5, and I have this, and I have 14. What does this implies? What this implies is this: if you want to read this statement, you need to understand that this is belongs to. Are you getting it now? And this is what? This Z. Anywhere you see this Z, it represents what? Integers. Are you getting it now? Z represents what? Integers. And they can use I at times. If they don't use Z, they can use what? I. So just note that whenever you see it, what it means is what? Is an integer. Alright? So how can we interpret this question? It's very, very simple to interpret. Just write down what? Q is a set. Q is a set of X such that X belongs to what? X belongs to set of integer between 5 and 14 inclusive. Now, you know, I've explained what this one simply means. That is, X is Q is a set of X such that X belongs to what? Set of integer. Now, if you look at this statement here, this particular one here, you need to understand it. What this one simply means is that what? X is a number between 5 and 14. X is a number between what? 5 and 14. Inclusive. That is, 5 and 14 is inclusive. And how do I know that it is inclusive? Because that this is what? Less than or equal to. Less than or equal to. Since it is less than or equal to, it means what? This one is inclusive. This one is also what? Inclusive. So if I want to write down what? Those elements now, I'll start from what? 5. Then I will have what? 6. I will have 7. I will have 8. I will have 9. I will have 10. I will have 11. I will have 12. I will have 13 and 14. So this is what? Set Q. Do you understand that now? So that is how to interpret it. Q is a set of X such that X belongs to set of integer and X lies between 5 and 14 inclusive. So you are able to write out the elements. Is that taken now? So let's look at the third one when it comes to algebraic notation. The third one in algebraic notation includes a situation whereby we have element X. Let's have it like this. Okay, let's say I have R that is equal to, let's say, set of Y such that, okay, I've interpreted this already, sorry, Y belongs to set of integer, let me say 2 less than, and I have X less than or equal to 5. Now if you look at this now, this is different from what we have initially, right? So what this one simply means is that what? R is a set of Y such that Y belongs to set of integers. And sorry, this is supposed to be Y, my bad. So this is supposed to be Y, not X. So this is what? Y. Yeah, this is Y. And you have this to be 2. So if you look at this one now, this one is just less than, right? What it simply means is that Y is a number between what? 2 and 5 such that what? 2 is not inclusive. because you don't have equal to here. So if you are going to write down element of R, you have it that R is equal to 3, 4, and 5. We include 5 because there is what? This less than or equal to here. But we don't include 2 because it's just ordinary less than. There is no what? Equal to. Okay, let's still move on. Okay, sorry. Let's still move on and look at the third one, the fourth one rather. So this is the fourth one now. If I have, let's say, set T is equal to set of X such that X is a set of natural number, capital N means natural number, between 2 and sorry, I thought I'm still using the X. Alright, so let's say this is what? This is X, I don't know, and I have this. Let me put this one like this, and I put this one like this. Alright, so if you look at this now, what this one simply means is what? T is a set of X such that X belongs to set of natural number. And if you look at this now, this means that X is between 2 and 5. And since this is less than or equal to, it means 2 is inclusive. But since this one is ordinary less than, it means 5 is not inclusive. Then you have what? Your T to equal to the set of 2, 3, and 4. So 5 is not going to be there. And the last but not the least, that is going to be our number 5. Number 5, if I have, let's say, set of A that equals to Y such that Y belongs to set of, let's say natural number. Natural number is the same thing as counting number, okay? And we have 2, and we have this X, and we have this 5. So what this one simply means is that what? A is a set of Y such that Y belongs to set of natural number, and sorry, this is supposed to be Y, my error. So this is what? This is Y. Alright, so Y now is a set of number between what? 2 and 5, and 2 and 5, they are not what? Inclusive. So A is equal to what? A set of 3 and 4. So do you understand this now? So that's that about algebraic set notation, and I believe we understand this, right? All right, so if we understand this perfectly, so the next thing we want to look at right now is that we want to look at the concept of type of set. All right, so let's quickly type that out. Types of set now. All right, types of set. So I want to believe that we are getting this explanation. Types of set. All right. Sorry for the noise. That's my daughter. Sorry. All right, guys. Okay. So what was the next thing we want to do now? We want to look at the types of set. We have different types of set, and I must tell you, we have about approximately 5 types of set, and I'm going to be explaining them to you now. So the very first one is empty set. I don't know, empty set. What do you call an empty set? An empty set is a set that there is no any element inside it. An empty set is a set that there is no any element inside it. It can also be called null set. Null, that is N-U-L-L. You can call it what? Null set, if you don't want to call it empty set. And it is written as this. So this is what? This is an empty set. There's nothing inside it. Note that you cannot have this. I've said it before. This is not an empty set though. This is what? This is not an empty set. It's not an empty set. It's not empty. Because 0 is an integer. Yeah, 0 is an integer. So if you have 0 here, it means you have an integer inside there. So it's not an empty set. But if you have this, it's an empty set. And it is denoted with this symbol, 5. So when you see phi or you see this one, okay, when you see phi or you see this empty curl bracket, you know that they are talking about empty set. Is that taken out? So number 2 is finite set. What do I call it? Finite set. So finite set. So what do we mean by finite set? A set that you know the whole of the numbers of elements inside it. That is, the numbers of elements inside it can be listed. You can list it. That's what they mean by what? Finite set. Why is this one not moving? Alright, so sorry. Don't understand. So when you say finite set, let's just move on. Finite set means you have what? The whole of the elements inside it listed out. You can list everything inside it out. For example, if I write down what is it called? If I write down the numbers of local governments, the numbers of local governments in Nigeria. This is a finite set. No matter how much it is, you can count it. That is, I don't want to know how much the so-called local government wants to be much. Are you getting this now? You definitely have what? You definitely have them counted all. Is that taken now? If you look at empty set, if I say, let's say a set of states in America that is in Nigeria. Like a set of states in America that is in Nigeria. None of the American states is in what? Nigeria. So it's an empty set. But if I say finite set, a set that you can count everything. Like you can list all the elements in it out. You can all write out the whole of the local governments we have in Nigeria out. Yeah, it might be much, but you can write it out. The same thing goes to the numbers of grain in a beans bag. So numbers of grains in what? Bag of beans. In bag of beans. It might be much, but you can write it out. Are you getting it now? It's a finite set. And another one is the numbers of students in Nigerian university. Numbers of students in okay, let's say in Ahmadu Bello University. So numbers of students in Ahmadu Bello University, you can count them. So it is a finite set. No matter how much they want to be, you can still count them. So to the fact that you can count them, make that set a finite set. Then we have the third one, what we refer to as infinite sets. We have what? Infinite set. Infinite set. So when you say infinite set, it is a set of number that you cannot count finished. You can't finish counting it. Like if I say a set of natural number. If I say what? A set of natural numbers. A set of natural numbers start from 1, 2, 3, 4 and dot. So you cannot finish counting it. It's just 3 dots. Don't let it be more than 3. Once it is more than 3, you are wrong. It's just 3 dots to represent that it is continuous like that. So if you start counting from now till Jesus will come back, you will not still finish counting. So that's why it is what? It is infinite set. And once you see this dot, it means that set is an infinite set. You can't finish counting it. That's why you see those dot. If it is a finite set, you'll be able to what? You will not see this dot. They will list everything completely. I believe you get this one cleared now. Alright, so if that should be the case, the next one we want to look at now is that is also an infinite set, is a set of let's say multiple of 2 is an infinite set. Multiple of 2 is an infinite set. Yeah, because by the time you start writing, you write 2, you write 4, you write 6, you write 8 dot. So it's just like that continuously. You can't. It has no end. So it is an infinite what? Infinite set. Is that taken now? If I say set of positive integers, set of positive integers. This is also what? This is also an infinite set. Are you getting that now? It is also an infinite set. So the fourth one The fourth one that we need to look at is a disjoint set. Disjoint set. And when you say a set is disjoint, two sets are said to be disjoint sets if they have no element in common. For example, if I have set A, and set A is what? A, B, C. And I have what? Set B, and set B is what? D, E, F. So if this is what I have, it means that these two sets, they are disjoint. Are you getting that now? These two sets, they are what? Disjoint set. Why? Because they don't have any element in common. And the last but not the least is what we refer to as equal set. Equal set. A set is said to be equal when they contain the same numbers of elements. Let's take for instance, I have set A to equal to 1, 3, 4, 8, for example, and set B is equal to, let's say, 3, 1, 4, 8, for example. So these two elements, these two sets, they are equal because they have the same number of elements. And when I mean the same number of elements, I'm not talking that they have 4. This one also have 4. No, I mean this one has 1, this one also have 1, this one have 3, this one also have 3, this one have 4, this one also have 4, this one have 8, and this one is also having what? 8. That simply make them to be what? To be equal. Is that taken now? So it's as simple as that. And the next one we want to look at is what is it called? We are going to start by looking at relationship between sets, and I think this is a very good place for us to stop. So part 2 of this lecture is going to start by looking at relationship between sets, and we look at Venn diagram, and we call it a day on set. So this is a good place to stop. So let me just drop this assignment for us so that we can we can just have it together in the next one. Or what do you think? All right, you can try this. Number 1, find the cardinal. Find the cardinal of the following. Find the cardinal of the following. So I have A to be a set of X which is equal to X such that X is less than or equal to 7, and X belongs to set of natural number. Okay, I think it's and X belongs to set of natural number. So I'm reading it for you. X is a set of X such that X is less than or equal to 7, and X is a natural number. So question, okay, let me put that there. B of that, we have F is a set. F is a set of Y. F is a set of Y such that Y belongs to set of natural number. 6 is less than Y. Sorry, my board is doing rubbish. I cannot start this time around. All right, so let me clean this up and rewrite it for you guys so that you can see. Sorry. All right, so let us just rewrite this. Okay, so F is a set of Y such that Y belongs to set of natural number, and 6 is less than Y. So that's the second question. And the last question that I'm going to give you is that find the power of the following set. Find the power of the following set. So A you have F equal set of 1, 2, 3, 4, 5, and B, you have G equal set of 2, 3, 5, and 7. So you have to find the power of the set. So this is just pretty much the assignment, and I think it's very, very simple. Thank you for your time. I'm very, very sorry for my pen. I believe with time I'm going to get better at it. So thank you guys. Meet you in the next class.